Assalamualaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. Today we would be discussing number systems, and this, if you are following the new syllabus, then this would be section 1.1, whereas if you are following the old syllabus, then this is chapter number 1 of your syllabus. So anyways, the contents are the same regardless of whichever syllabus you are following. So let's get down to it. So basically in Cambridge there are 3 number systems that are a part of your syllabus. There are many other number systems available as well, such as octa number system and so on, but they are not a part of Cambridge syllabus. In Cambridge you only have to deal with 3 number systems: binary number system, denary number system, and hexadecimal number system. So before we start with the conversion between the number systems, that is the major portion of the syllabus, let's first briefly discuss what these number systems are and where they are used, because sometimes the examiner asks these type of questions. So the binary number system is based on the number 2, or you can say it has the base 2. It only has 2 digits, either a 1 or a 0, because a computer or a processor cannot understand anything else. The combination of these 2 digits make up binary strings, and it is strictly used by computers. It is very difficult for humans to remember, read and write. Then we have the denary number system. It is based on a number 10, or it has the base 10, because it has the digits from 0 to 9. So 1 to 9 makes up 9 digits, and 0 is the 10th digit. This system is used by humans for everyday calculation. For your everyday maths all around the world, we use this system. Then we have the hexadecimal number system. It has the base 16. How? Because it includes 0 to 9 10 numbers and 6 alphabets, 0 to 9, and then A, B, C, D, E, F. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15, whereas 0 is the 16th character. This system has replaced binary because hexadecimal is much easy to read, remember, and debug as well as write. See, 0 1 1 0 0 0 1, something like this is very difficult to remember, read and write correctly without error, whereas 3AF, this is easier to remember, this is easier to read, this is easier to write and debug. If I have mistakenly written this instead of 3AF, then it is easier to locate and correct, whereas if I've mistakenly done this, then it is very difficult to find along this binary string. Okay, so moving on, converting from binary to denary. For example, we have a number 00 11 00 and 11. What you need to do is, first of all, put place values in power of 2 on top of each bit. So what you need to do is, so what's our number? This is our number. So first start putting powers of 2. 2 power 0. I'll just open. So our number is 00. This is our number. Now the first thing you need to do is put place values in power of 2, means and start from the right hand side, means like this: 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, 2 power 9, 2 power 10, 2 power 11, 2 power 12, 2 power 13, 2 power 14, 2 power 15, 2 power 16, 2 power 17, 2 power 18, 2 power 19, 2 power 20, 2 power 21, 2 power 22, 2 power 23, 2 power 24, 2 power 25, 2 power 26, 2 power 27, 2 power 28, 2 power 29, 2 power 30, 2 power 31, 2 power 32, 2 power 33, 2 power 34, 2 power 35, 2 power 36, 2 power 37, 2 power 38, 2 power 39, 2 power 40, 2 power 41, 2 power 42, 2 power 43, 2 power 44, 2 power 45, 2 power 46, 2 power 47, 2 power 48, 2 power 49, 2 power 50, 2 power 51, 2 power 5, 2 power 6 and 2 power 7, like this. Now there are some people who would directly write, or there are some students who would directly write learn and write it as 1, 2, 4, 8, 16, 32, 64, 1 to 8. Now whichever method you follow, that is fine. If you want to go along with this, this is correct. If you want to go along with this, that is also correct. It's up to you, because if you solve this, this is going to give you this value. 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 5 is 32, 6 is 64 and 7 is 128. Anyways, so this is your first step, putting the powers on numbers. The next step is, wherever there is a 1 in the binary string, you can ignore the zeros. You have to note down the place value for that. Like for example, 2 power 4, that means 16, and 2 power 5, that means 32. And then the next one we have is, the 1 has the power of 2 power 1, that means 2, and 2 power 0, that means 1. Now all the numbers which you have just written, from the place values or from the powers, add them together, and this is going to give you something like 51, and that would be your answer. Now in order to make your answer more accurate, just give it a base of 10 to show that you have converted it in denary, like I have done over here. Okay. Secondly, if you have to convert from denary to binary, simply draw this type of table, write down the number and take LCM with 2. 228s are 56, nothing is left, put a line and write 0. 2 14s are 28, again nothing is left, put a line, write down a 0. 2 7s are 14, nothing is left, line, leave a 0. 2 3s are 6, over here is 7, so 1 is left, make a line and write that 1, the remainder over here. Then 2 1s is 2, but this is 3, so 1 remainder is left, so write it over here. Now start reading from over here and gradually move upward. 1 1 1 0 0 0, this would be our answer, and this would be the value of 56. If you want to check it, we can do it by 1 1 1 0 0 0. Now we can ignore the 0 part. Okay, so over here the value for this one would be 32 plus 16 plus 8. This would give you 16 plus 8 24, 24 plus 32 is 56. So that means we have done correctly. Now the next thing is, in paper you're often given grids such as this one, and you have given a number and then you're asked to fill in the values. This is usually not given, this is also not given, and you're simply given this. Okay, you are given some working space and you are told by convert this 56 into binary. So what you do is, after this conversion, you always have to start writing from the rightmost bit. First of all, count the number 1 2 3 4 5 6, and if you count it over here, 1 2 3 4 5 6 7 8, there are 8 boxes and you have 6 digits. So how do you fill them? Always start filling them from the right. Okay, like this, 3 zeros 3 ones, and then you're left with this. The empty boxes you're left with, just put a 0 over there. Do not fill the binary string from the left like this and then add the zeros at the end, otherwise your answer would be wrong. How? See, I have solved this. This turns out to be 56, but if I solve this, this turns out to be 224, so your answer would be wrong. You are going to lose your marks. So please never fill the given grid for a binary or a register from the left hand side unless you have 8 digits. Unless you get your answer as 8 digits over here, then it's alright whichever way you fill the grid with. But if you are getting less than 8, then always start filling from the right. Means you are going to start writing from there. You are first going to write this, then this, then this, from the right hand side towards the left hand side, then this, and then this. Next, converting from binary to hexadecimal. For example, this number 10110011. Split that binary string into a group of 4 strings, assign them place values, and add together the place value of ones. Now this is rather easy. We have 8 numbers, convert them into group of 4s. 1011, this would be the first, and 0011, that would be the second. Simply write 1 to 4 8, or 2 power 0, 2 power 1, 2 power 2, 2 power 3, and then add the place values for ones together. 8 to 1, this becomes 11, that means in hexa it is B, and 2 plus 1 equals to 3, so the answer would be B3. First of all, we write this part, means the part on the left hand side and then the right hand side, and this becomes our hexadecimal answer. Now if you have less than 8 in your given question, for example 101100, now 1 2 3 4 5 6 7, this is 7, so simply add a 0 or as many zeros as you have to on the left hand side in order to either make it 4 or either make it 8 or 12. You have to make it in a multiple of 4. Let's suppose this is your number 1 2 3 4 5 6 7, so you add a 0 on the left to make it 8, and let's suppose this was your number 1 2 3 4 5 6 7 8 9 10, so you add 2 zeros to make it 12, so you can make it into 3 groups. Okay, always remember to add a 0 on the left hand side in order to make it into a multiple of 4, and then break it into groups of 4 and then solve individually. 4 bits in binary make 1 digit in hexadecimal, just remember that. Next we have from hexadecimal to binary, simply convert each bit, each number in hexadecimal into 4 bits. How? For example F60, so for 0 all the values would be 0, so that 0 plus 0 plus 0 plus 0 becomes 0. For 6, 4 plus 2 is 6, so just write down 1 in place of these 2 bits, whereas keep the 8 and 1 bit off. For F means 15, you have to turn on all the 4 bits, because 8 plus 4 plus 2 plus 1 equals to 15 equals to F. Lastly, write all the pair of 4 bits together in one string like this, is again starting from the left hand side, and this would be your equivalent answer of F60 in binary. Converting from denary to hexadecimal, the method is similar to converting into binary. Just take an LCM, but this time take an LCM with 16. For example, you have the number 1059 to 1666 1056, 3 is remainder, then 16 4 the 64, 2 is remainder, so 4 2 3. Again we start from the bottom and move gradually towards up. 4 2 3 with the base 16 would be the answer in hexadecimal. Converting from hexa to denary, again we put place values. For example, this is C25, sorry, this is C, Now C25, put powers in terms of 16, 16 0, 16 1 and 16 2. This is 16 0 is 1, 16 1 is 16, and 16 square or 16 raised to power 2 is 256. Now what you need to do is, whatever number you get by solving this power, you have to multiply it with the actual number, or you can say that multiply the place value with the value of hexadecimal character. This is the value of hexadecimal character. You have to multiply it with its relevant place value. So 16 power 0 is 1, we multiply it with 5. 16 power 1 is 16, and the number hexadecimal number is 2, so we multiply it with 2. 16 2s are 32, and then the value for C is 12, and we multiply it with the value of place with the place value. 16 power 2 is 256, so 256 multiplied by 12 is 3072. Now we add all these three together and we get 3109. We have converted our hexadecimal into denary. Uses of number system. Binary number system, as we have discussed above, it is used by computers. Denary is used by humans in everyday calculation. Now the important part, uses of hexadecimal number system. You have to remember at least 3 uses, because the examiner asks for 3 or more uses. In memory dumps, you don't need to write any detail for it, just remember these phrases, or just remember this uses. HTML color codes. Now do not write HTML codes or just color codes. You have to write HTML color codes. And then assembly language programs, MAC addresses, error messages, and IP version 6 addresses. Okay, again, you do not need to remember or write any details in such type of question. You just need to write down simply the uses. That's it. Now this is something which was there in the old syllabus, and they have not specifically declared it as out of the syllabus for the new one. So we are going to solve it. Working of a control system using microprocessor and registers. What happens is that you are given a register. A register is simply a memory space that can have 4, 6 or 8 bits. Okay, and registers are used to store commands in order to operate something such as a vacuum cleaner, a toy car, or a toy remote control aeroplane, and so on. For example, a toy car is controlled by a microprocessor and an 8-bit register. Now you are given a diagram in which you have given front wheel A, front wheel B, back wheel C and D, which are joined by an axle. Then they give you the diagram of a blank register, and they tell you that if this bit is on, that means wheel A turns right. If this bit is on, that means wheel A turn left, wheel B right, wheel B left, back wheels forward, back wheels backward, power on, and this is not listed. This might be for power off. Now if you have a code, now the examiner either gives you a code and then asks what does it mean, or either he gives you a scenario and then asks you, okay, what would be the code in the register in this scenario. So for example, 10101010 would mean wheel A is turned right. Okay, see, if we write it like this, simply use a pencil to write it. Okay, and wheel A is not turning left, then wheel B is also turning right, and then we have a 0, that means the left function is off. Then there is another one, that means that back wheels are also moving forward and backward functionality is off. And then we have another one, that means power is on Okay, it means that wheel A is turned right, wheel B is also turned right, back wheels are moving forward and the power is on, hence the toy car is turning right. Okay, now if you have given this number, it means that wheel A and B are not moving, are not turning anywhere. Backward wheels are going backward, power is on, that means the toy car is reversing or moving backwards in a straight line. Now if you have all the zeros or all the ones, that means power is both on and off. This means it has an error. Or if all of them are 1, that would mean that wheels are turning on towards left and right at the same time and the power is on and off at the same time, which is wrong. It cannot happen. So in such a case we would write that this is either used to test the system, whether the system is capable of displaying error message, or either the system has encountered an error. Okay, so this is the part 1 of your lecture. We have gone through all of the binary conversions. I'll see you guys in the next lecture. If you have any problem, feel free to ask. Take care. Allah Hafiz.